So my name is Anthony Caparelli. I am a bartender, host of Art of the Drink TV, and also a mechanical engineer. So when I started bartending back in I don't remember, it's a long time ago, just having graduated from mechanical engineering, what I realized was all I knew about bartending was what I saw on like Cheers and TV shows, and everyone knows bartenders are the guy behind the bar and they give people advice. That's what bartenders do. What I found out when I actually became a bartender is the one thing bartenders like to do, even more than give customers advice, is give other bartenders advice. They love that. And what they like to do, rather than tell you what to do, they love telling you what you can't do, what you absolutely can't do that. Right? You're laughing because you all seen this. You all have bartender friends like, you cannot absolutely ever shake a drink that has, I don't know, whatever in it. Orange juice. Can't do it. You can, obviously, do it. So the question is, should you, and when should you not? So when Drambuie, our very, very gracious sponsor, offered me the opportunity to set up literally a laboratory-grade setup and test some of these bartending myths and legends and common wisdom, I just jumped at the chance. This is literally something that I've wanted to do for 2 decades. So I have spent probably the last 2 months running experiments for you guys so that you now will be able to go back to your friends, especially those bartender friends of yours, and when they start telling you what you can't do, I want you to say, yes, I can, and here's why. Because to me, as I said, my website is Art of the Drink. You should check it out. artofthedrink.com, and I chose that name very carefully because to me bartending is an art, and it's creative, and it's about encouraging creativity, not stifling creativity. It's about what you can do, not about what you can't do. All right, so that's what this seminar is going to be about. So I have assisting me on my right, Nicole DiMattei, professional bartender, and on my left, yes, clap, absolutely. Look at her. Got all dressed up. Dave McCoy, who is a professional scientist, 10 years experience. And Dave and I have designed all these experiments with as close to lab-grade accuracy as we can, given the time constraints allowed. And I will continue to do this because I get to play with all this equipment now. So I will continue to do this. So as we're kind of going over these things, jot down some questions that you guys may have and send me emails later afterwards because I'm going to be looking for other things to test and follow up on, all right? And you'll be able to go to scienceofmixology.com and get this whole presentation and all these results because it gets really kind of geeky, and I'm going to skip the geeky stuff because it's too early for that. All right, so geeky. It'll be there. Don't worry, it'll be there. I'm just not going to waste your time too much with it. So we are going to start with one of the latest and greatest is craft ice. Now everyone who, where's my Scotch drinkers? Let me see, hands. Scotch drinkers, oh wow, yeah, Manhattan Cocktail Classic, I love it. Okay, so what's the biggest trend in Scotch right now is the craft ice, right? Everyone serves a monolithic block of craft ice. So what I did was, I knew kind of what I wanted to test. So I went on the internet and I said, let me see what people are actually saying about some of these practices. And I found out that we got a lot of opinions and not a lot of data. So that's what I tried to do is kind of put some data. So this is one of my favorite quotes. I'm just going to read it to you. The amount of dilution you get from bad ice is considerably more than larger ice cubes. Larger ice cubes meaning cubes 1.5 inches square. Bad ice meaning shell ice that you typically see coming out of commercial ice machines. This is off of Chowhound, right? That's someone who really kind of has a strong opinion, and they put it out there as a fact. So I said, well, let's go ahead and test that. And you can see Dave is actually going to be running some of the experiments behind me as I'm talking about this stuff. So hypothesis, because we always start with a hypothesis. Hypothesis, using a large single mass of ice to chill a drink will result in equal cooling compared to multiple cubes of the same mass, in other words, smaller ice cubes, with less dilution over the life of the drink. And that's what's implied, right? When you use a big cube of ice, what's implied is that you're going to get less water in the Scotch. But it's a big cube of ice, so it's probably going to stay just as cold. Well, as an engineer, that didn't really ring true. So what I did was, what we had to test, I changed the shape of the ice and the mass of the ice. And what I was measuring was how does the temperature of the drink actually respond over time to see if it does what people say. And you'll see slides like this throughout the seminar. I may talk about them, I may not. But again, you can find this stuff on the website. For those scientists and people who want the geeky stuff, pay attention to these slides. You can see what we hold constant in this particular experiment is we use the same volume. That's important. We make sure that the drink temperature is the same before we put the ice cube in. And then obviously the glass shape, size, blah, 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 blah. And I performed this particular experiment, there you go, 3 times. And you can see this is the craft ice, and this is the cubed ice. So what I did was I actually checked, because I had a theory of my own. My theory was that the mass of the ice has nothing to do with it. It's the surface area of the ice, right? People are nodding. So what I did was I ran the craft ice. I'm sorry?
So you have more points of contact.
More points of contact, right. I ran the craft ice, then I used equal mass of cubed ice, which is more surface area, and then I used a smaller mass of cubed ice with the same surface area as the craft ice. Does everyone follow that? All right, so let's see what happened. Then we measured the temperature, and I did all the stuff that you need to do, and we checked all the temperatures and held everything, blah, 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 all that good stuff. The other thing that I wanted to do was I wanted to figure out at the end how concentrated the sample was compared to the beginning and the end. How much dilution did we actually get? Whether that part of the common wisdom actually held true. So I went ahead and got this spectrophotometer, which I really like. This is my new favorite toy. And I measured the concentration, very scientifically, before the ice went in and after the ice went in. Well, here's what we found out. Over the time of about 10 minutes, which is what I tested for, you can see that first top line is the craft ice temperature. So over here, we start with a drink at about 75 degrees. After about 11 minutes, the craft ice goes to about 43 degrees. The ice that has the same surface area but less mass tracks that curve almost exactly. So you can see that using a smaller mass of ice with the same surface area is going to give you almost exactly the same effect as using the craft ice, which is why I chose to give you your first drink, which is Drambuie, thank you to our sponsors, using regular cubed ice, just 2 cubes. And those 2 cubes have the same surface area as this sphere of craft ice that we showed you before. Okay? As far as dilution curves go, here's your dilution curves. And again, look at the one on the right. You can see that the craft ice goes down to about 28%, and the cubed ice goes down to about 27%. That's cubed ice with the same surface area, less mass. All right, the cubed ice with greater mass, the dilution is greater because it has greater surface area, so greater melt, which is exactly what we would have expected. So in conclusion, we have to reject the null hypothesis. We have to reject that initial statement that we saw off a Chowhound. Using a large single mass of isochill drink will not result in equal cooling. It's the surface area and not the mass or shape of the ice. So I want you guys to go ahead and enjoy your Drambuie through the rest of this presentation. That will get you started.